Ladies and gentlemen, hello and welcome back once again to the briefing room. My name is Eric Cavanaugh. I will be your moderator for today's event. I love this title, When Worlds Collide, Bridging BI, Analytics, and Operations. We're going to be talking about what I think is a very hot topic. It's a very pressing topic, quite frankly, and I think that it's going to be such a significant subject area that we'll probably have a whole month dedicated to this next year in the briefing room, because it's not just integration anymore. It's not just ETL. There are a lot of things happening out there, and companies need to really get a handle on how to piece all of this stuff together. So there is a slide about yours truly and enough about me. Let me go ahead and move through here. Many of you know by now the mission of the briefing room is to reveal the essential characteristics of enterprise software. So we take a slightly different approach than most other organizations in that we first have myself do all the value proposition up front, then a vendor will give a technical presentation for 20 minutes or so. The analyst then gives a response and then just starts asking questions. So we are literally exposing a live analyst briefing for the benefit of a virtual audience, namely you folks out there. I can tell you that your questions make these briefings really, really detailed and valuable, so please do not be shy. You can ask any question you want. We try to get to each and every question during these events, and we usually get lots of them. So we cover a different topic every month in the briefing room, and the reason being is because I'm always putting myself in the shoes of the end user, and if you're about to pull the trigger on a 5 or 6 or 7-figure deal, you want to make sure that the technology you're buying is what you think you're buying, and you want to make sure it's going to work for you. So you want to have the details that you can get, as many of them as possible, and that's why we have a different topic every month. And also because my background is in journalism, and I want to make sure we have some kind of editorial framework for what we're doing, such that we're not, as T.S. Eliot once wrote, shifting in the wind like a field of ripe corn. So, if anyone is having trouble with the slides, I'll go ahead and push a URL of the slides themselves. You should see May the Analytics page right now. So analytics, what are we talking about? There's this whole world of business intelligence and then this side world of analytics that has kind of risen up. A number of different vendors have been focused on it for a variety of reasons and for a number of years, but it seems to me that there is something of a chasm developing between traditional business intelligence and certainly this world of big data analytics, but business analytics as well. So a number of vendors have done some very innovative things in terms of data visualization and data exploration, and that's great stuff. It can reveal all kinds of interesting patterns in your operations that you can streamline. But one thing that we keep seeing are these new silos. Of course, a silo is a single location. So we don't want silos. The whole data warehousing concept was designed to serve as a marshaling area for critical data, such that business analysts and other analysts could take a hard look at the numbers and understand what's going on in their business. Where's the profit coming from? Where's the money going? What are we making money on? What are we not making money on? Well, now we have these fascinating worlds of analytics and BI, but how are we going to stitch them together? And then a bigger question, how do you tie that all back into the operations of your business? Closing the loop, as an analyst said to me about 10 years ago. How do you close that loop? How do you make use of all this intelligence, all these analytics, and still keep a handle for what is going on in your organization? So our analyst today is Shawn Rogers. Very happy to have him on board. He's a real entrepreneur, a media-savvy entrepreneur in the industry here. He has been around for a while. He really focuses intently on this industry, so we're very pleased to have his experience in play. We're also going to hear, of course, from Composite Software. And these guys have been around for a good long while. They've been doing data virtualization arguably longer than most, if not every other major vendor in the space. Of course, some of the big guys have been doing a variety of things for a long time as well. But in terms of those independent pure plays, Composite has been around for quite some time. So they have really focused on this data layer, or the data fabric, as my partner Robin Bloor will call it. And I've heard people talk about this now for a good 10, 12 years. A consultant I know, Michael Haston, called it an enterprise backplane. He called it that 15 years ago. So it's been around. It's been in use. But we're going to learn about what's new and what's happening today on the show. So Bob Eve is the Executive Vice President of Marketing over at Composite, but he's not just a marketing guy. He knows a lot about the ins and outs of the industry and the technology, so we're pleased to have him on board today. And with that, I'm going to pass the keys over to Bob. And folks, I'm going to go ahead and post a link to the slides as well so you can download them for your own use. So with that, Bob, the floor is yours.
Thank you, Eric. Hello, everyone. It's great to be here today. Get to talk about data virtualization and analytics and really the integration that's required as all the new analytic silos and types of analysis come into play with new machine data, social data, the traditional types of analysis, and some of the new trends that are changing how we do integration, not just why. What I want to start with is just this idea that says big data analytics, mobility, and cloud computing are really kind of breaking the traditional data integration model, data integration approach around the enterprise data warehouse. I'll kind of talk about some of those trends and how over time things have changed. Then I'm going to jump to the approach that's brought into play by data virtualization, and then give you a couple starting points for moving forward in data virtualization. The first point I wanted to make is that CIOs care a lot about these factors. If you look at this survey from IBM, I've circled 3 of the top things that CIOs are concerned about. The first being business intelligence and analytics, and I think you can see that that's easily the top item, and that was true in 2009 and remains true in 2011. And I think even more so in 2012. What's happening, though, is I think there's probably a shift between business intelligence and analytics. That's that column's combined the two, but I think analytics is on the rise. Business intelligence is becoming less critical, but in total, you can see that nearly 85% of, or 87% of CIOs rate that as one of their top issues. Of course, mobility is rising, and then cloud computing, that's the one that's shown the most dramatic change over the last several years. So these are the technology drivers, these are the things that CIOs are concerned about, and these are the things that are changing how we're doing analytics and why we're doing analytics. So let's take a journey back in time. Back in the day, when you wanted to do analytics and business intelligence, you'd build a data warehouse. It was great. It was one place to go, and it provided a business view of the data. And I've got a little agility meter up there in the right corner. Now, we all know that it takes a while to build a data warehouse, but once you've got that data warehouse in place, you know, as a new information need comes in from the business, if the data is in the warehouse, it's pretty quick to get a new report out to fulfill that requirement. So data warehouses met our traditional data integration needs pretty well. But then business wanted more operational data, not just historical data for analysis. Wanted to bring in some of the up-to-the-minute transactional data. Wanted to start accessing data from SAP or Oracle or other applications built on relational databases. What the response was, we could make the data warehouse work, but we needed some new data integration techniques. Maybe some operational data stores need to be brought into the mix, some change data capture to do updates of the data warehouse in a slightly different way, a little more incremental, maybe data federation across the, some of the ODSs and the data warehouses. So that kind of made the existing model worse. We lost some agility along the way because this is a little more complicated, more moving parts, but I think for the most part, we were able to bring operational data into the environment. But then some new information technology came along. First, there was the what I call the fit-for-purpose analytic stores or analytic appliances. Netezza is probably the most well-known. I remember 2 years ago going to the Netezza user conference and speaking with the guy who sold to one of the large banks. At that point, 2 years ago, they had 40 Netezza appliances in the bank, and they were just getting started. We all know that Oracle now just has the database as well as Exadata and some other different types of data stores. So we get the analytic appliances, we also started getting cloud data. Salesforce and NetSuite, give a couple of examples, where people's core CRM and financial systems are being held in the cloud, and that's really critical data that would need to be combined with other data to get a more broad view of the business. More sources, more types, still trying to make that work from an integration point of view to get that unified business view of the business. Next came some new IT paradigms. So it wasn't just new technologies like data warehouse appliances that were based on SQL. These are brand new approaches, web services, which requires all new integration protocols and techniques, and big data as well. I mean, there's a reason, NoSQL, not only SQL, however you want to speak to it. I mean, MapReduce has nothing to do with SQL. And when you have 99% of your people in the IT department who know SQL really well and about 3% who understand MapReduce, you've got a retraining and education program, and so in new kinds of tooling and new kind of integration approaches. So what we're seeing is more and more of these silos proliferating, and it's really challenging how to do data integration, and it's really slowing down the business agility because now you need to provide information across all these sources to these consumers. But wait, there's more. We're getting more and more different consumers as well. How many people on this call have multiple devices? How many people on this call sit in their office all day and just interact through their PC, or do they travel? I guess, Shawn, you're in Orlando today. I mean, you've been on your iPad, you've been on your iPhone, you've been on your PC, and next week you're in Las Vegas. I mean, your headquarters is in Boulder. You're traveling all the time. You're gathering information about your business. You're looking across all of those things. You need to pull all that together. So what we've really described here is a whole series of changes in information management in technology, and how that's really changed the integration landscape. And the answer to this complexity and trying to bring some agility back is data virtualization. And what we do with data virtualization is embrace and extend the enterprise data warehouse. It brings back those core principles of the enterprise data warehouse, one place to go. It just happens to be one virtual place to go. And then the other concept that people love about the data warehouse is the business view of the data. And frankly, it's a real view or a real set of views. So with the data virtualization platform, you can abstract the taxonomies from the source data, kind of build a schema, a business schema that people on the business side, up above here can understand. You can federate across the multiple sources, and you can optimize the queries as well as optimize leveraging the different source technologies. So those together combine to form a data virtualization platform, and that hides that complexity of all these diverse sources, and it deals with some of the challenges of the multiple different types of consumers and the latencies that start to become involved when you get a landscape that's this complex, this global, this many different mixed workloads. So I've talked a little bit about how change is occurring that sort of broke the traditional data integration paradigm around the enterprise data warehouse. Let's talk about how we can bring data virtualization to bear to provide that agility to the business and to IT. First thing you have to do is get a data virtualization platform. Here's a diagram of ours. The way one needs to think about it is all the different use cases and business use of the information, whether it's business intelligence, customer experience management, profitability, revenue maximization, governance, risk and compliance, single view of enterprise data, SAP data integration for all you people calling in from Sapphire. Those are all different types of reporting and analytic use cases that you want to support, and you want to leverage data from all the multiple sources inside and outside your enterprise. Well, the data virtualization platforms have three components. There's the development environment. This is where you understand, using a product like our Discovery, you introspect the sources, understand them, understand the relationships, attach to those sources through our adapters, and then use a studio to develop your views or data services. So that's kind of development time and the complete set of activities to provide software development lifecycle and support that. The information server is really used at runtime to perform the on-demand queries. So as the requirements, let's say we want to run a business intelligence report or an analytic of some kind, it queries down through the information server. The information server then pulls the data to the source from the sources and delivers to that analytic or that report. And then the management environment, of course, is the ongoing reliability, availability, scalability factors, and managing that at an enterprise SLA. So that describes the platform. Let's go back to a couple of the concepts that underlie an enterprise data warehouse. One, as you recall, is the idea of one place to go. And what I'm presenting here is what one virtual place to go. I know this is a bit of an eye chart because there's so much content on here, but this column really describes a number of the adapters or the source, how we attach to different sources. If you go back to this diagram, all these different sources, how do you attach to them? But it's more than just attaching. You really want to understand from a query optimization point of view what the capabilities are. So if this is a Hadoop cluster, how do you best use queries on that? If we're a data warehouse or if we're using Netezza, that's going to work differently than Greenplum or Teradata. And so how do we maximize the performance of queries that utilize those sources? So we want to have adapters that not only connect to those sources, but leverage the optimizers in those sources. And we do that through capability files and a really intelligent use of push-down optimization. Then there's the delivery interfaces. To support all the different consumers. Let's go back up here. If you think about the consumers, maybe these are reporting applications, maybe they're mobile devices and we're consuming through REST. A lot of different ways to go in terms of the delivery of the data. And then, of course, you want to have some caching capabilities that provide some flexibility so that you can, it's not just black and white, virtualized or consolidated. We can flexibly use caching and it kind of covers some of that gray area, provide the security that's going to be required if you're going to be surfacing data across the enterprise. And so those are the kinds of things you need to have one virtual place to go. Business view of the data. We've borrowed this slide from our friends at Forrester in their, it was published about a year ago in their Data Virtualization Reaches Critical Mass report. In this, they really describe the concept of canonical business models. So think in the middle what these views of customers or orders or products might look like. Those are used across multiple applications, and maybe this orders view looks a little different to this application than it does to this application because this application might require be a REST call or a SOAP call, and this might be an ODBC call through to a reporting engine. And then it's really conforming and staging the data and analyzing the data and delivering it into an abstracted form that we can use here in a canonical form. So that's how we get a business view of the data. And for those of, when I say view, I'm literally talking about views across multiple databases. So one logical place to go, or one virtual place to go, and a business view of the data. That's really the enablement that allows data virtualization to pick up that same kind of benefits of a data warehouse with greater agility. What are some of the paths to get there? Well, I'm going to keep this real simple. Kind of a commercial for us, but I think Eric started this by saying Composite's been around a while. For 10 years, we've been working with some of the world's largest companies on their toughest data virtualization problems. You benefit from that because we've solved a lot of those issues and worked through advancing technology, advancing capabilities, etc. And we now have, capabilities that have been proven in multiple domains, be it financial services, the federal government, life sciences companies, the high-tech providers, energy firms, media and communications companies. So really a wide variety of consumers or of companies are using data virtualization today to gain agility. You want to work with people who are data virtualization domain experts. So it's, know not only the technology, but know the use cases, the business processes, the best practices, and know what it takes to be successful in implementing. And one of the things we've done is literally wrote the book on data virtualization. And in the book, it's a 200-page book, 150 pages really are detailed coverage of these 10 use cases. So you get a full concept of what the business problem was, what the technology solution leveraging data virtualization looks like, the sources, the consumers, the activity, the virtualization transformations in the middle. What's the ROI? And what are the next steps? So a lot of kind of a full picture of those different deployments across multiple industries. And then finally, one of the things that's just really important is having a business case that makes sense. And I think if you're going to get started in data virtualization, you have an advantage because you can actually self-fund the project just with savings, hard dollar savings. And I've got 3 examples here. First is the New York Stock Exchange. We all know who those folks are. And Euronext, that combines with another 12 other exchanges around the world. They saved $4.5 million on their first data virtualization project alone. So that first project more than funded their entire efforts. And you can go to our website, and then these are actually YouTube videos. If they look like YouTube videos to you, it's because they are. You can go to our website and click on these videos and listen to Emil Ware from the New York Stock Exchange describe his deployment directly. And they're also covered in the book. As is Qualcomm. Their first 5 projects, they saved $2.2 million. Again, funding their entire data virtualization investment several-fold. And they started with just a couple of projects, and they've managed to complete 24 projects in 2 years. So they're knocking out a new data integration project every month. And I think that's a pretty fast pace. That and I'd urge everyone on this call to compare that with how they're doing internally. Are you able to get a new data virtualization project or new data integration project knocked out every month with a very small focused team? Finally, I got another case here from Comcast, and they used the Composite data virtualization for some customer care applications in and around their triple play or quadruple play services. And what they've been able to do is really pay with increased customer satisfaction because they've got 0 downtime customer care apps, and that just provides thousands and thousands of dollars every day in cost savings as well as customer satisfaction. So it's not that hard to fund this, and I think in today's financial times, it's really critical that when you're making a case for new technology, that it's great that technology pays for itself and can pay for itself within a year. That's what I wanted to cover. We talked about the trends that are changing the data integration landscape, the kinds of mobility and big data and cloud kind of adoption that's changed analytics, changed business intelligence, how that's made the data integration approach, the old let's get everything in the enterprise data warehouse because that's one place to go and it provides a business view of the data, how that concept is sort of broken down. But through data virtualization, you can provide one virtual or place to go and a real set of business views of the data, and you can do that with agility and with some reliable technology and it can self-fund. So I think it's a pretty good combination. And for
All
more
right.
information, you can go to our site or look for more information on the Data Virtualization Cafe.
Excellent, excellent job. Okay, and now Shawn Rogers, you are up next. I'm going to go ahead and pass you the keys to the WebEx car. And you should now have them. Just click anywhere and use the down arrow on your keyboard. And folks, awesome questions already. Thank you so much, Bob. You might want to take a gander at that Q&A area because we've got a bunch of really good ones already. So we'll save that for the Q&A. But Shawn Rogers, go ahead.
Eric, thanks a lot. It's great to be here today. And Bob, I agree with everything that you talked about today. Change is definitely upon us, and you know, we've been taking a close look at some of the things that are driving change in kind of people's data ecosystems, and we've identified 4 of them, and I think that they come to bear, make change, as you pointed out, and also, of course, open up opportunities for technology like yours. And I'm going to speed along because I've got quite a few slides today, but as you read along with me, there's really 4 things kind of coming to bear on all of us right now. A maturing user community, much more complex workloads, much greater demands on our systems as we move from business intelligence to advanced or just analytics in general. Certainly technology has risen to the risen up and gotten a lot easier to use, a lot faster, a lot smarter, and I'm talking both about hardware and software there. Obviously economics come into play. We're able to do things today that we weren't able to do 10 years ago from a cost perspective, and that's certainly opening up the doors for innovation and change in our data landscape. And perhaps last, you know, data always plays a role here, and whether it's new types of data like sensor or social or machine-generated information, or even good old-fashioned just unstructured data that we've kind of not been able to work with in the enterprise over the last handful of years, all of this is kind of coalescing and coming together to create new opportunities. And frankly, it's putting an awful lot of pressure on our data warehouses. And that's not to say that the EDW is dead or that you should move on or abandon your investment, because that's certainly not the case. It still plays a very critical role here. But alongside of the data warehouse, new technologies are sort of finding their way into our world. And here at EMA, we tend to, tell our customers, hey, think about what's happening now. Don't worry about what's happened in the past so much, and embrace some of these new technology so that you can innovate and move forward. We kind of call this switch the hybrid data ecosystem, which is a great analyst word to just describe change. Things are definitely moving forward, and at the heart of it is really this need to match your data and your complex workloads to the best possible platforms. And as you do that, as both Bob and Eric mentioned, you do run a risk of creating silos, and you have to be careful. And I do think that that's where data virtualization and data integration innovation in general kind of come into play. And in this new landscape, as I mentioned, we still have the enterprise data warehouse, but we also have data marts and operational systems, analytic platforms, as Bob pointed out. And I agree with Bob. These are getting heavily used right now, and new cutting-edge technology like big data and certainly cloud-based solutions. And you start putting all of these in this ecosystem, and it becomes more difficult to manage and becomes more widespread, and certainly demonstrates, or at least presents us with new challenges on how to manage that data. Bob made a comment about my travel schedule, and he's absolutely right. We live in the day of bring your own device, and I carry multiples. I've got an iPhone and an iPad, and I'm on my MacBook Pro right now, and this is my office. And I've been using a collaborative system this morning, working on a project with John Myers, one of the folks that I work with at EMA, and all of these things become these sort of new analytic delivery platforms. And to tie them together, you've got to have a data integration tier that makes sense, that has innovative features in it, certainly has to have agility. Bob mentioned some of that, and I'm going to ask a few questions of Bob on that topic in a minute. And it makes the case for maybe looking at data virtualization as an enterprise-wide implementation. And we'll talk with Bob about that, I think, a little bit too, because I think this is a type of technology that you all might want to be starting to think about in a much wider stance than you may have in the past. Ultimately, as we commit some of our information to some of these new platforms, matching the data and the workload to the platform, we're going to find ourselves with some data that we just plain don't want to move. And that data might be in a cloud, or it might be in a big data framework. And if it is, it may not be practical from a time or a cost standpoint to actually physically move the data for analysis. So once again, data virtualization, innovation, and data integration technologies come into play. I'm not going to belabor too much, but I think the big opportunity also here is going to be on the data management tier. How exactly are we going to manage these widening ecosystems as more of these platforms find their way alongside of our enterprise data warehouses? What are we going to do to tie them together and manage them transparently? And I think that'll be a topic that you'll see EMA spends a lot of time worrying about in the next couple of months. And right now I'm just doing a build just to sort of drive home the point that we started out with this enterprise data warehouse, and we're definitely moving well beyond it, and there's not much any of us are going to be able to do about it. That's for certain. So for those of you who are traditionalists and are a little nervous about this sort of new technology stack that's heading your way, pay special attention to the delivery tiers. Spend some time looking at how you can better manage the workload, the metadata information, how you can govern these new platforms as they enter your ecosystem. And by all means, I always tell anybody who talks to us about a widening ecosystem, you need to partner with somebody who understands the data integration aspects of it. Data virtualization, I think, is a tool that everyone should have in their toolbox. And if you don't, you ought to probably start looking for a way to do it, even if it's for simple solves, like I mentioned, data that's probably better off not moved. So once again, just a couple of things from my standpoint about as your ecosystem enlarges and you are faced with these new challenges of managing these new areas, make sure that you have a balanced attack. Don't be afraid to step away from your enterprise data warehouse and take a look at new tools. Understand the workloads that you want to execute and plan accordingly and get the right tools for them. I think that it is economically sound. It's a great way to serve your more sophisticated users. We're seeing a lot of people save an awful lot of money with these new platforms, and we also, I think, ultimately are able to serve more complex analytic needs. And I think that those are a couple of things certainly to take into mind today as you're thinking about introducing these new types of technologies. Bottom line, they'll create brand new value for you, and certainly massive opportunities across the board from your data standpoint. So Bob, you and I are in agreement. Things are changing. Silos can be an issue. Tying these worlds together is going to be highly important, and certainly a subject matter that's worth talking about. So let me get into the Q&A side, and I see they've got a bunch of my questions up here already, Bob. So I'm going to start with the top one. You made the case for agility with data virtualization, and I'd kind of like to know a little bit more details on how and where that comes from. You mentioned three areas of the platform, the development side, the management side, the server side. I think for some of us today, looking at that slide, it might have looked a little complex. Where does the agility come in, and how do you help your customers, I guess, execute on that?
Yeah, it's a great question, Shawn. And in the book we talk about three classes of agility: the kind of information agility, getting the the complete actionable information. We talk about time to solution agility, kind of a more streamlined, iterative, easy to change approach. And we talk about resource agility, more higher productivity for the developers, better use of the infrastructure, optimization of the various integration techniques. If I had to simplify all that, I'd put it this way. If you think about how you do data integration today, you get a set of requirements, you go introspect and understand the source, profile the source data, you start to define a schema, then you start a mapping, then you have to write the ETLs to move the data from the source to the schema, then you move the data. And that's a lot of moving parts. If you're going to do that with data virtualization, you would use a product like ours. We would do the discovery and the introspection to understand the sources. The schema you want to build is a set of views, and you just start building the views from your kind of that mapping function that you do in a classic data warehouse build is really a view building function in Composite. And you've got the views, you've got the data. There's no load involved. There's no synchronizing of the schemas, the ETLs, and the mapping tables. So you really just can much more rapidly get the data in front of the business user. So companies like Pfizer, they can, less than a week, they have complete data sets out to the user, sometimes even within a day. And that just helps them move so much more quickly and hone in and fail forward on the business requirements. So I think that's probably the jump start initially, and then you just keep getting that agility, year after year, because you continue to extend the existing analytic and the existing reporting.
I like the phrase "fail forward." At the core of that value proposition is you're talking about closing the loop a little bit here between the demands or the needs for the data and the ability to deliver it.
Yeah, absolutely.
Yeah, that makes good sense. So next question is, I was just talking about what we call the hybrid data ecosystem. I think I understand where you guys fit in it, but where do you see data virtualization enabling companies to embrace this kind of widening change in their landscape?
Well, I think first of all, what people are realizing is that they are getting this widening change in their landscape. They're getting these multiple silos. They're deploying the fit-for-purpose stores. I'm sure at one point, the guys at the bank I was talking about earlier didn't even realize they had 40 Netezza appliances deployed. They're starting to get really intelligent about the workloads and where to put the work. And sometimes you move the analytic to the database. And I think people are accepting that. So I think that's the first part, is just understand, we're going to have the silos. We're never going to get it all into the big enterprise data warehouse. So once you accept that, a lot of the value is in just the agility in getting that data integrated. So I think that's the kind of the two-step process. Understand that this hybrid ecosystem is reality, and then what's the consequence of that? Well, we've got all the stuff deployed optimally in individual silos. Now, when we want to do analysis across those silos, what's the best way to do it? And we think data virtualization is a huge advantage.
So when, one of the things that, gosh, I've heard it a lot again this week, and it's coming up more and more in conversations, is this need for near real-time or right-time sort of analytics, the speed component to what everybody's trying to solve. And, from a performance standpoint, how are you able to address the needs around that particular side of analytics?
Well, it's a great question. So I think in the cases where you want to have a real close coupling between the analytic and the data store, there's no need to introduce data virtualization in the middle of that. Just get right to it. For those kind of high performance analytics, and so get that data and that source closely aligned. Now, when you're thinking more broadly and how do we integrate that silo with another silo, that's where I think you pick up a lot of advantage. And, the technology is certainly fast enough to do that, because at this point we are leveraging these fit-for-purpose stores. We're usually not we're analyzing more broadly or querying more broadly across a wider set of data. We're not trying to build the warehouse in every query. We're just querying that particular data set. And we've had, a lot of years of Moore's Law and improvement in network speed and technology kind of a head start, as well as all the hard work that the data virtualization companies have done to optimize their queries and to think of new and advanced query management techniques. So I think it's really understanding mix and match approach, solve each problem based on the workloads, apply caching when appropriate, et cetera.
The caching part's a good topic. Can you expand on that just a little bit and how that works to speed things along?
Sure. I think we all understand the concept of views, and we all kind of understand the concept of materializing a view, which is kind of a temporary creation of that persisting of that data. Now, data virtualization products provide a lot of flexibility in doing that materialization of the creation of these caches. You can determine how often you create a cache, where to put the cache, how to update the cache. Do you update it in total or do you update it incrementally, kind of like a change data capture? And there might be data sets that you think are smart to persist, and you can use them to kind of help you with performance. One case we have is one of the large computer companies integrates their entire supply chain and leverages Composite data virtualization to do that. We're able to integrate that supply chain because they have a really good product master that lets us join on the part IDs. But what we do is we cache just certain columns out of that part master so that we can go to that cache frequently and join to it in a high performance fashion. That's just one type of flexibility that the caching provides. And really it's sort of this gray area between full virtual and fully consolidated, and it's just a nice set of tools in the data integration team's toolbox to give them even more flexibility and agility in terms of deploying.
Okay, and that certainly makes sense. And I might have segued you into the next question I had, and maybe it has to do with your caching technology. Obviously companies are getting rather global nowadays, and it's not uncommon for us to have data that we may want to bring together for analysis, different data sources on different sides of the world. And when we get into logistical distance, we're always going to obviously have some form of fairly inherent latency just because of the miles between from one system to another. How do you help your global customers with those types of challenges, or are they just sort of stuck with the latency issues?
No, I think you can totally work around the latency issues. One thing you have to remember, just kind of simple physics. The networks are the slowest part of the equation. Right. The memory is the fastest. The disks are slower than the CPU and the memory, and then the network's the slowest part. So for 10 years, we've been building technology for optimizing that mix where the network's the slowest part. What we've done is we globalize and we move people around, and we have trading desks in Singapore and Frankfurt, New York, and San Francisco and London. We're just facing real latency type issues, and so what we can do in those cases is use a combination of the query optimization and a kind of a staging of caches out to those different locations, and really reduce the amount of distance and create local caches in the different sites, and I think overcome a lot of this global distributed query challenge, especially in things like trading where time is absolutely of the essence.
Now, is that something the platform will do automatically, or is it something that you configure, or both?
It's more configured because you kind of have to understand a little bit of the nature of the deployment and the use case. What you do with caching is you kind of let the optimizer figure things out the best it can, and then you analyze where the bottleneck might be. So for example, a moment ago I was talking about the computer company and integrating their supply chain. Well, you ran those optimizations and we kept looking at the bottleneck, and the bottleneck was the scans of the million row part master, looking for the parts to do the join on. Well, we said, well, how do we work around that? So we configured a cache. That's really easy to do, but it's just not automatically, hey, we should create a cache. We don't figure that out for you. You kind of do some analysis, and then we help you tune that. So it's really easy to do. And as I mentioned, there's a lot of flexibility, but it is manually configured.
Okay, great. So you talked a little history before, so I'll talk a little as well. Data virtualization or technologies similar to it have been in the market for a while, and as you well know, even in the 90s, some of the data warehouse purists were tough on that technology. When I think there was terms being kicked around, virtual data warehouse, and federation was a common term, and then I think a little later on we got into EII, and those technologies I think were foundational to the data virtualization market that we see today. But I guess I'd like to know what's changed, how has it evolved, and why is it right today, maybe more so than it was then?
Sure. I think you're right about kind of some of the history, and I mentioned really one of the things that changed has been environmental, and I talked about networks and databases and memory getting faster and that sort of thing. So we've gotten some tailwinds, frankly, that I think face some of the guys trying to do this in the 90s didn't have. Those were definitely headwinds for them. I think probably the major changes have been in terms of breadth. Over the years, we've kind of gone from a SQL-only point of view to today. It's much more of a SQL and services and NoSQL sort of mixed topologies, or another way to put it would be, structured, semi-structured, and unstructured. And then the other thing is, I think the focus has gone just purely beyond historical reporting and analytics to a much wider, what's happening in the past, what's happening now, what's going to happen in the future, and can we support this range of data and servicing it to this powerful new set of analytic and self-service BI tools.
The next one on my list, and I think I alluded to this, and I'm curious as to how you feel about the challenges. I honestly think that as the ecosystem gets wider, it might behoove companies to really seriously consider widening or making enterprise-wide a data access layer that they can control and manage. And that may not be all data virtualized data. It could be ETL and everything else that goes into data integration. But how do you feel about companies attempting to implement data virtualized layers much wider than they are today? And do you have people that are doing it? And what kind of headaches have they seen trying to go that big with it?
Yeah, it's very interesting, the evolution in the last couple of years, Shawn. I would say 2-3 years ago, people bought us primarily for point data integration problems.
Right.
And, hey, we really can't solve this using our old techniques, and we're going to think about this as a point solution, a tool in our toolbox. And I'd say over the last couple of years with some of the trends both you and I have talked about today, the companies now are really thinking about this data access layer, data virtualization layer, business view layer, semantic layer, something across their enterprises that's going to provide some agility and deal with this mix of technologies. And in last year, 2011, half of our new customers bought with that in mind to begin right from the start. Now, they might have implemented a project first. You got to start somewhere, but they were building an architecture. They were deploying an architecture, and the project was just, one of many projects in the process of that long journey. You mentioned, like, what are the consequences, what are the headaches, what are the things? I think as you think bigger, you start to think more about governance and data models and reuse right from the start. You think more about how this is going to fit in your integration competency center. In a couple of words, you think more people process than you probably do if you're thinking about, a tool and a technology. So I think just bringing that point of view that they've established maybe in their enterprise data warehouse practices or their BI competency centers, bringing that point of view to this layer, it's a pretty easy transference, a lot of the same principles, a lot of the same organization, a lot of the same roles, et cetera. So, but it is a definite change than just like, let's go knock out this problem.
Yeah, well, and one of the things that comes to mind on this is, one of the first point that I made on things that are driving all of this change is this more sophisticated user. And I think that this push towards self-service business intelligence and analytics is also very real. It's part of that new sophisticated maturing user. And they don't necessarily want to go down the hallway all the time to ask permission or ask where or how to go and get their hands on data. If you have a unified data layer, one that is enterprise-wide and easy to understand, it empowers these people a bit more.
Absolutely, and I think it changes IT's role and responsibility. IT really becomes a service provider to the business, literally. I mean, so we're going to, as a service, we're going to give you this layer of kind of cleaned up, rationalized information. It's going to be one virtual place to go, and it's going to be a business view of the data. And go knock yourself out, business guys. You got some smart folks. There's great new tools out there, the clicks and the tableaus. There's these predictive analytics products, Alpine and Prediction. I mean, there's just some great new stuff out there. And hey, the old reliable Excel. I mean, geez. So you've got all of these great tools in the hands of these power users. Just give them the data. That's all they need, and they will bring value to the business.
Yep, for sure. My question at the top of this page is a good one, I think. You know, obviously, I think data virtualization's got an application. I said it up front. I think it's a tool most companies could probably find a use for in their toolbox, but you know, there's got to be times when it's just not appropriate. When doesn't it work, and when do you dissuade a client or customer away from using the solution on a particular challenge?
Sure. I think probably the most well-regarded business or most highest use case of data consolidation or data warehousing is the kind of time series analysis, historical time series analysis, where you're going to redimension the data from its original stores. You're going to run new sums by region or by time period or by sales or product and all the whatever dimensions you're going to kind of reanalyze the data and remodel it. And so if you got a star schema and you're doing that sort of thing, that's the perfect application for a data warehouse. You really don't want to throw that away. I think the biggest challenge is we've used that deployment, that data warehouse deployment, for every data integration problem, not just the time series historical analysis problem.
Right.
I think there's that a new case, like with the new types of analytics, these when you're analyzing clickstream data, et cetera. I mean, there's certain. I mean, you guys, your company gives people advice on how to do this, Shawn. But you know, certain of these analytics, you know, you want to move the analytic to the data. I mean, and you know, so you run that in Hadoop and MapReduce, and you're running some algorithms to look at clickstream data or to look at some other machine-generated data. You know, certainly those aren't good use cases for data virtualization. What you might do is take that result set and then join it with some other, and want to include that with other information to, for example, see the effectiveness of your marketing campaign, not just the clickstream activity. So I think those are a couple of cases.
Yeah, and you're back to the heart of the conversation, which is let the right tools do the right work. So that makes good sense. I almost always get asked questions about data quality when I get asked questions about data virtualization. So where do you see data quality fitting into the process, and do you guys offer data quality features, and what do you think of it in general?
Yeah. So first of all, let's think of what's the SLA around data quality. What are we really talking about? What's the business use? What's the need? With that in mind, the types of things we tend to be involved with are things that would be considered conformance, validation, making sure the data is accurate. Certain things that are more complex data, and we provide all those capabilities. Things that are kind of multi-step, maybe with some human intervention, kind of that are more of a process flow, and you want to persist the result. Like here's Shawn Rogers with 2 G's in Rogers, and here's a Shawn Rogers with 1 G in Rogers. Can someone look at this and tell us what's right? That's a manual intervention, and when you're done, you probably want to go back and write back to the original source that there's only 1 G in Rogers. And so that's not the kind of thing we do. That's you need a really quality data, data quality specialized tool to manage that kind of a business process, or a data quality business process.
Okay. All right. I think you mentioned big data, so have I today. It's certainly buzzworthy. Is it a significant opportunity, and what are you guys doing around Hadoop and other big data things to sort of enable your customers?
Sure. So first of all, what are we doing, and then I'll talk about the opportunity. So what are we doing is we can view Hadoop as a data source, along with maybe some of the data in SAP and some of the data in your Oracle database, et cetera. So you could get a kind of a federated business view across these different sources. So in that case, we're sort of sitting above Hadoop and the other sources. Because we might have access and we might be managing the data in other enterprise sources, we can sit underneath Hadoop, and Hadoop can query us. For example, that's another case. So both of those cases, what we're doing is integrating and extending beyond the Hadoop stack. Now, that's what we can do. What do we see people actually doing today? What we see doing today is deploying their initial Hadoop analytics. And they're not too worried about integration just yet. Right. They're just really focused on getting those silos up and running. I'll contrast that with the analytic appliances, the Netezas, the green pumps, et cetera, that really started coming into deployment big time 3-4 years ago. That's what people are integrating today. At least that's where we see the heat map. So I would say we're probably a year or two out from integrating the new silos, these new big data silos, but the technology is ready to go today.
Well, I think that the comment about the analytic platforms is spot on. They broke the barrier on this kind of new hybrid ecosystem. They were the first. I think data marts and operational systems found a natural path to our environments, but the first kind of really true outsider to step into the ring, as it were, with the analytic platforms, and they were very disruptive when they arrived. But they've definitely found a home, and I agree. I see a lot of big data solutions kind of doing the sort and sift or the pre-processing of large amounts of information, but a lot of the analytics are getting done back on the analytic platforms, and they've definitely become a home for that.
Yeah, and I think the thing you've captured in your hybrid data ecosystem is, there's different kinds of analytics and different types of workloads, and the concept of fit for purpose. And then, I like all the little bits, the ones and zeros transferring in between the different silos in your diagram, because that's kind of the sense of now we're going to query around that. We may actually move some of the data, but probably move a lot less data than we would have thought of 5 or 10 years ago. Yeah. What we really just need to do is query across those on demand.
Well, and that goes back to, when I asked you the question about real time. I mean, certainly not every workload requires write time or real time, and I would assume you see a pretty large or various mix amongst the people that have done multiple projects on your platform.
Yeah. One would have thought that would have been the driver.
Yeah.
Certainly it is, for some of our data warehouse extension cases, because we want to see, everything up until last night's in the warehouse, but we also want to join in today's data, for example. And that's certainly, then that timeliness is the difference that's making the difference. That's why they're doing the project. But there's other cases where I think the business view of the data, the kind of the abstraction kind of concept is what people are really looking for. And the fact that it's on-demand data is great. That's nice. But it's not the difference. It's the difference really the abstraction, the one place to go, the logical or virtual the views, and those seem to be the things that are the main drivers for making a change. And by the way, but wait, there's more. Your data is up to the minute. So that's kind of what I've seen in terms of deployments from the customers.
Well, I know we're bumping up against the top of the hour, so I'll ask you, I think the last question that we haven't really answered was second from the bottom of this page, which is, I'm curious as to what you see as being what's next, or what, what do you see entering this ecosystem in the near future, or from a connection standpoint, a data source standpoint, or what do you think is going to be the next hot topic?
Sure. I think the business view layer or the semantic layer, that interaction with these power business users, that is going to be a big area of development over the next several years, making it easier to find the data that exists in the enterprise that IT's been serving up. That's going to be critical. I think the fact that this recognition of these different silos in the hybrid data ecosystem, there's going to be a need for more planning, control, and management across those. So I think you kind of capture that in your diagram, and I think we'll be working on those sorts of things. And then finally, just the continued diversity of technology, the diversity of the consumers, the diversity of the sources, just constantly keeping up with those, and then finally just pushing the envelope on performance. We're always pushing the envelope on performance.
Well, that makes sense. Well, Bob, I enjoyed the conversation. Thanks. Eric, I think we've exhausted most of my questions. Are there any others we need to ask?
Well, we have a whole slew of them here in the Q&A, so we're going to go ahead and dive right in. And Bob, you're not off the hot seat yet.
Okay, let's keep going.
Okay, so I'm going to push one of these other slides. I thought this was a really interesting one that you had here. One of the attendees asks, in a complex environment like slide 9, I actually pushed slide 21, how do you manage a single business view virtual layer where there are constant changes in underlying systems?
Sure, it's a great question. So what you do is and you build this layer, and you can see these customers and orders. There's some work you do in between here. You might have these databases that we've introspected and understood, and then we start to build views on top of those that then sort of conform to get us to customers and get conformed to get us to orders. You know, maybe we change num to integer, we get part ID, product ID, prod number, and part number all lined up, you know, with a business term like part number. So we do some of that work in conforming the data. One of the things by keeping a close linkage between the original source and the view in our layer is we can run nightly introspection and see what's changed in the sources. And when we see that a source has changed, we just change the view, or maybe add a view or refine it. So it only breaks that view. It doesn't break all the reports and stuff above it. And we can, one of our customers, Pfizer, Mike Linares, is really interesting. He says, well, you know, I got a great relationship with all the people who manage the source data systems, and they always tell me whenever they're going to change one of the source systems, but just in case, every night I run an introspection across all my sources to see if any of them have changed, and just to be sure. So he comes in every morning, just double checks to make sure none of the sources have changed. And if he has, he can quickly just reconfigure the view and make it work.
Interesting. Okay, good. The old trust but verify, right?
There you go.
This is a really good question. It's kind of extending beyond exactly what we're talking about today, but I think it's a useful question anyway, and I think you'll enjoy fielding it. One of the attendees asks, as we move from analytics to predictive analytics to projective analytics, what is the end game, if any, to this process? Will we ever reach a command and control environment a la the military battlefield systems, and if no, why not?
Well, I think there's just some real challenges in pulling together the intelligence. We're getting better and better at pulling together the data, but it's the interpretation, the human part, modeling the brain. It's the models. That's what's tough. By the way, anybody needs a job, get yourself trained as a data scientist. There's zero unemployment. And why is that? Why is there such a need for these folks? Is because it's their job to kind of convert the world, the real world, to this modeled world. And once you then model it, you can then leverage the data and have it start providing insight into what happened, what's happening, what's going to happen, and what might happen.
Yeah, here's a question that I'll go ahead, Shawn.
Oh, I was just going to add, that goes hand in hand with the comment that I made about the hybrid ecosystem. That the layer that's going to be really tough to deal with is that command and control environment, right? This ability to see all, manage all, do it transparently. And I think that what we're going to end up seeing is the big stack providers, they're extremely excited about helping all of us manage and see and bring together analytics in a stack that's just about them. The big guys have analytic platforms. They have cloud offerings. They're bringing big data solutions to market, and they're willing to help their customers manage them. The problem is they don't want to manage other people's environments as well. And so I think the opportunity for a command and control system for analytics and insight is going to come from a smaller, innovative company that doesn't have partnership ties and wants to come into the market and help people solve this problem. So, I think it's probably going to be a difficult aspect of a hybrid system for the next couple of years until we get an innovative player to step in and help bring all those things together, above the data integration or data virtualization layer. So it's going to be a tough thing. It's a great question, though.
Well, and it kind of brings up a question that I had myself here, which is one area we did not talk much about. Is that third leg of the stool here, which is operations. So, Bob, let me throw this question out to you. How many of your clients are actually using this virtualized data layer to feed operational systems, whether it be a CRM or an e-commerce site or whatever the case may be, is that happening to any significant degree, and if so, how?
Oh, yeah. Both from operational data sources at the bottom of our diagram, so to speak, and operational applications. So like campaign management, best offer, that sort of thing. You know, what happens at the screen pop at the call center? That's different. You want that to be different depending on the person who's calling in. And in order to make those decisions, you need to understand maybe their lifetime value from the data warehouse. You need to go out to SAP and see their last 10 shipments. You need to go over to Siebel to see their last 10 returns, perhaps, or maybe the invoicing system to see where they are in their payments. You want to look at what's been happening in terms of their behavior on the web. So that's a lot of wide different data, and based on that data, you may want to treat that person differently in real time on the phone at the call center. So these are classic type of use cases that people are leveraging the information for. So it's one of the things Comcast is doing, for example.
Yeah, it seems to me that it's a tremendous use case to avoid, again, some more of these silos, because really because a lot of times I think what happens is you get data replication for stuff like that, right? You'll just kind of peel off some data, buy a replication server, send it to the operational folks. That way they get something in real time or near real time. But once again, you're just kind of siphoning off and creating this sort of temporary silo, whereas with a well-managed data virtualization layer, again, performance is always going to be an issue, but that's why you say you're always focused on that. So I'm glad that we can kind of touch on that a bit. So here's another good question. One of the attendees wants to know, is in this virtual environment, can it play the role of the presentation layer? In other words, can it be modeled according to requirements of the user-facing applications?
No, I wouldn't go so far as to say it's the presentation layer. It's the data layer that we would use to then use visualization or analysis tools over the top of. What you want to model is kind of common denominator entities that might be used across multiple reports or multiple analyses and multiple applications. So, maybe there's a concept of something called gross margin, and that requires data from revenue data and cost data. Well, if you've pre-modeled gross margin, then you can use that gross margin across multiple reports and visualizations and analyses, and then use whatever tool at that point, whatever visualization or analysis or reporting tool that a user is comfortable with. So what we see people doing is building like canonical models of frequently used information objects, and then that's one stage, and that's kind of the top of our stack, and that attaches to the bottom of the visualization or analysis tool stack.
Okay, good. And here's another really good question. One of the attendees asks, in a complex environment, how is provenance handled? In other words, can you query the virtual data model and understand where data is coming from and how it has been transformed?
Absolutely. Absolutely. Full lineage, you can trace it all the way back to the sources. We can even keep track of, when the data was queried, et cetera. So you see the entire structure or lineage, and you can see the timing.
Okay, here's an interesting question from one of our attendees, I believe, who's overseas, and writes, what does discovery mean on the development side of this equation?
Sure. It's a great question because I know folks like ClickView use that term in terms of business discovery. Here, I think it's more like a profiling. We go in and introspect the data sources to see what tables are out there, what views are, what tables, what are the rows and columns and stuff, the nature of the databases that we're introspecting, and then we do relationship discovery across multiple databases. Now remember, we're looking across multiple databases, so a lot of times you're profiling a single database. We're profiling across multiple. We're understanding them, discovering relationships between things like, oh, over here in this system they have something called prod ID, and they have this in this other system they have something called part num. Looks like 97% correlation between these two. Do you think it's a relationship? So we try to help people jumpstart some of those things that you do as the pre-step to modeling. So
okay,
that's
good.
really what we're trying to accomplish.
Sure, and here's another good question from an attendee. You've talked about this before on some of the past shows, and folks, I put a link to the archives in the chat feature so you can hop online and see what's going on there. But where is the master data and metadata stored in this virtual environment, and how does that work? I mean, as you bring in a new system, for example, I would imagine you scan the column headers and that kind of thing, and how manual is that process, and how does all that work?
So there's certainly the metadata that comes from all the sources, right? So every table has its DDL, or every system has its DDL. We have the DDL for the views that we create. So we have all the view definitions, and we carry extra metadata for things like cardinality and have the sources and stuff so that our optimizers can have that information readily at hand. We can ingest the metadata from other systems. So for example, if you built some unbound models in one of the modeling studios like Embarcadero or ER Studio, you can bring that in, and we can then bind that to the sources so we can leverage existing metadata. So we carry, within our product, we carry all the metadata that we need to have in order to, both model, run, and manage the virtual queries. The master data, typically the master data is set up in advance. We're querying a parts master or a customer master, or maybe some of the reference tables, financial services, all the table that defines all the different financial instruments, for example. So those are often tables that we include in our views, and oftentimes we even cache some of those frequently hit tables.
Okay, good. We get just a few more good ones here, and then we'll be all done. These are great questions, folks. So here's another one. One of the attendees says, I've seen Composite software use Kapow software, and curious if this is a required piece of the stack or if Composite Studio is preferred. And folks, FYI, we did Kapow in the briefing room just a couple weeks ago, so you can find that in the archive. So can you talk about the relationship between what you do and what Kapow does?
Sure. Kapow has some really unique capabilities for harvesting web data. So they can read data off of screens, frankly. Composite is more optimized for reading data from XML documents, hierarchies, databases, SAP, PeopleSoft, Siebel. So we're more, we go to databases for our data. Kapow can go to screens across the web for their data. So what we actually do is team up with them. So if someone has a use case where we want to federate maybe some Netezza data, some DB2 data, some SAP data, and some pricing data off of a competitor's screen, off of their website or something, then pull all that together in one common view, and then serve that in Composite to any consumer. So we team up with Kapow in any of those kinds of cases.
Okay, good. And here's a nice curveball for you. One of the attendees asks, if data virtualization is not addressing silos, isn't it just another remedial pattern, more middleware for working with middleware?
Well, it's middleware, and it does work with other middleware. So, for example, we might do a query and pull together a data set and load that onto an ESB, and that ESB might then transform it, transport it, across the World Wide Web to some other consuming app. So I I think that answers part of the question. I think most of the time our purpose in life is to deal with the fact that people have silos. And they want to span those silos and see value in spanning those silos. So that's the value. Otherwise, if you only really have one silo, one database, everything's in the EDW, and you don't have a lot of agility concerns in terms of what it's going to take to get things that aren't into the EDW into the EDW. Or if you only use one database or one application to run your entire business, you probably don't need data virtualization.
Right, and of course we must remember the age-old adage that perfect is the enemy of good, right?
Yes, absolutely. And I think a lot of times what people are finding is that the perfect concept of the enterprise data warehouse, one place to go, business view of the data, is a wonderfully perfect concept. It's just never we're able to implement it. But we can get pretty close with the combination of physical and the capabilities that are out there today already with the warehouses that have gone a long way. And then we virtualize the rest, and we deliver one virtual place to go and give the business view of the data. And what's not to like about that?
That's right. Well, let me just get to two more really good ones here. So I love this question. How is the data layer rationalized? In other words, what level of description is provided to the business users that would allow them to successfully use the data made available? Seems like it would be easy to query for the wrong data thinking you have the right data.
Sure. I think a lot of that is in your view definitions and the extensions and the metadata you put around it. Some of the business/IT analysts who support it. But it's a vocabulary, right? It's a business dictionary kind of a challenge, and the more work you put in to getting it right to begin with and making it really clear, the fewer inadvertent errors you're going to make. Absolutely. What we see people doing is typically jumping in really quickly, getting some projects up, getting used to the technology, and then kind of sweeping back later and saying, we could have done that a little better. We could have had a little better hygiene on these definitions. We could have had a little more consistency. At that point, they're just changing views. It doesn't really break a lot of things. So they sometimes they just add some of that hygiene and consistency later.
Yes, good. Oops, okay, hold on. I just sent one out to the whole audience there. I didn't mean to do that, so disregard that chat, folks. Let me give you one more question here, Bob. Hold on one second. This is a really good question. I'm going to push this slide, too. One of the attendees writes, what is the definition of the canonical business model? The data model? If yes, how many entities, attributes, and relationships? If no, what is the structure?
I'll give you a case. One of the large oil companies in the world, upstream, their business model their canonical model has things like wells and pipes and different types of liquids and equipment that form the physical world of drilling for oil. They've got 600 canonicals they've defined. They used very good practices for doing that. They used the Embarcadero products for creating those, managing those, and then they bound them to the sources using Composite. So that's an example. I can't really tell you, how many entities that covers, how many terabytes of data. That's, how much that's been rationalized. I could probably research some of that, but 600 canonicals is a pretty impressive feat. And the guys at Forrester, who I want to thank for this slide, think it's a pretty impressive feat as well.
Okay, good. Well, folks, I hope we got to all your questions. If not, we've just gone through 78 minutes of great content. So a very big thank you to Bob Eve of Composite Software. A very big thank you to Shawn Rogers entering the briefing room for the first time. We appreciate his time and attention here. And that's the upcoming list of topics. Actually, in July, we're going to do disruptive technology. We're going to have a company called Phasic Systems in there, and that's going to be a very, very interesting show. Anyone who has not heard of them should check them out. We do archive all these webcasts. I went ahead and pushed a link to the archive in the chat feature a few minutes ago, so feel free to check that out. I'll go ahead and push it once again just so you folks all have it there. But thank you very much for all of your time and attention today, folks. We do appreciate it. This archive will be up probably within about 30 minutes or so, pending any strange technical issues. But with that, we will finish our broadcast, and thank you again so much. Great presentation, great job, both Bob and Shawn today. And we'll catch up to you next week with SAP. They're going to be talking about how to integrate Hadoop and MapReduce. Boy, that's a good strategy for dealing with open source integrated. So this does conclude our broadcast, folks. Thank you again so very much. Take care. Bye-bye.